My name is Tian, and I run a small software agency. And we mainly work with the startups building web and mobile applications. And we use Elixir and Phoenix as backend, React and React Native for front end and mobile. And the most apps we build is kind of API driven and also WebSocket driven as well. Depends the nature of the application. So today I'm going to be talking about Elixir and Phoenix, and also a little bit about microservices. I've never really used much microservices myself until I taught Richard and about just different things, and he's really familiar with all the microservices stuff, and he asked me should talk about Elixir in this kind of space. And then so I did a lot of research because Elixir is supposed to be really good on this, and just because the application I've developed so far don't really require microservices, but so I just explored a little bit and found it's actually really interesting. So that's the thing I will be talking about a little bit today. And just quick hand up, anybody knows Elixir? Oh, that's perfect. So I can talk anything I want then. Yeah, right. Okay, so So first thing is we need to talk about Erlang, because Elixir is built on top of Erlang VM, and Erlang was created back in 1980s by Ericsson and built for telephone switches. And so you can see the model here is you have switches in the middle, and you have different nodes, different telephones around the world. And Erlang been known as really resilient. And the uptime is 99.9999 or 569 anyway. So there is still running a Ericsson system. I think they only done about six hours in the last 20 years. And then so you can see how good Erlang as platform is. And but you look at the model though, and what I'm mainly working with is the web or mobile, but I think it's really similar, right? So you have middle part of the servers. Servers kind of like the switches for the old kind of a telecom system. And you have a lot of browsers or mobile devices or IoTs, whatever, and it requires your server. And your server need to route your data into different backend endpoints. So even though the Erlang itself was built for telecoms, but it actually totally fit for the this web model. So one big use case WhatsApp, they have 2 million connections on single node. It's beefy machine, obviously. It's not really kind of a small machine, but it's still the way, because the nature of WhatsApp, is constantly connected. It's not the traditional web way, a request response kind of thing. So the WhatsApp is a messaging platform. And but when they sold to Facebook for 16 billion, they only had 13 employees, including one person was a cleaner. So they actually only have 12 engineers, and out of those 12, I think there were 8 or 9 were actually system engineers, and one mobile engineers, and one web engineers, and another guy doing different things. So you can see actually how powerful Erlang is. So you can there's just few big companies using Erlang. And in here, Dublin, I think Dimware, they're building the backend servers for PlayStation networks and Blizzard games like World of Warcraft and those things, the backend for them. But they don't use Erlang entirely on their stack. They use Erlang as a routing kind of layer. So all the traffic comes in, they use Erlang to distribute different traffics into different servers. And so that just shows Erlang is really fast on this part. And but why Erlang is so good is not popular, right? So I think these days most companies using Java, Scala here, and Node.js, or different things. But Erlang just being around for so many years. Why Erlang is not widely adopted if it's such a good platform, right? And I think a few things about that is Erlang was created by Ericsson themselves. They use internally, so they only open sourced them, I think, in 1990s. And then the tooling around that wasn't that great. So they built by a single company, they use everything internally, and they have all the kind of management processes but when the open source, like people just use it, and there was no like a single kind of a repository of like place you can find the packages or libraries like npm or like Ruby gems and stuff. And then so most people actually back in the days in Erlang, what they do is they go to some GitHub, find some code, they copy the entire code into their code base instead of actually like install like using proper like kind of package managing like software. So like this Elixir. So Elixir, this is from their website. So Elixir is just a dynamic functional language designed for build scalable and maintainable applications. So it was created by a guy called Jose Valin, and he was the co-contributor of Ruby on Rails. So he, at the time, he was in charge of kind of like finding this problem with Ruby on Rails, the thread safe problem. So there's, because Ruby is single-threaded, and then when they try to share, like run multiple processes, and they, especially this old design language as well, they share a lot of state, and they have like a lot kind of polluted data sometimes, and then so they want to prevent those happening. And then so he started researching on this field, and then, but the Ruby just doesn't really have a good kind of concurrent story. So he was looking at the different languages to see what other languages, how other languages doing this concurrency, and how do they solve the problem. And then so he found Erlang, and he really loved it. He actually fell in love with Erlang, so the platform itself, so it's great. And but then he just can't bring that back to Ruby. And but then he saw some limitation for Erlang. One thing for Erlang is the language itself, the syntax itself is actually inspired by Prolog. And it was functional programming, and but it's kind of it's not really extensible. Like they create a list of kind of syntaxes, and that's how you use it. But it's like in order to create some more kind of like well-defined libraries, and just not flexible enough. And then so Jose Valin decided to give a try to create a language itself based on Erlang VM, because the VM itself, just like JVM, is really good like a virtual machine. And so like, but he came from the Ruby on Rails world, so he really kind of obviously know the web programming really well. So he decided to just do something, maybe can bring some of the web programming kind of things into Erlang world. So he created Elixir, and then so. But the one thing he had in mind was developer productivity. And he wanted to create a language that's easy to use, and then they have a good toolings around, the good documentations, and then with all the good libraries around. Yeah, so just a few things about Elixir here. Actually, just copy all of them on the website. You can find all of them. I just want to kind of explain a little bit about each point, or why Elixir claim those things. So the first thing is the scalability. So this is a little bit weird if you look at this, because Erlang had this thing called OTP, Open Telecom Platform. It is a set of libraries. The name itself, like everybody talking about, the name is not really a good name, because the original developers, obviously, they want to create a set of libraries for Open Telecom Platform. But the more and more, they added so many libraries to it. And then in Erlang, also Elixir, actually the process itself is primitive. It's like an integer. It's like it's like a double. It's like whatever, and it's like those is a type. It's just a thing in the language itself. Not like most other languages, you manage like the processes using external software, other applications. So you have one single application, and then you have other software managing all your applications. But in Erlang Elixir, actually there's a thing called supervisor. You're actually managing process itself internally. So that's why you create this thing, you actually can create a process and send to another process if you want to. But this case, you only send to itself, just hello world. And then because this pattern, so it's actually a pattern. So what it does is it pass message around. So you have one thing, process, you can pass message to another one. So it doesn't matter if it's on the same machine or multiple machine, they're the same way. So that's why also Erlang, this OTP platform, they're really powerful. They managing the process is not actually the system process. They create this like internal Erlang, like a beam, like it's a virtual machine. The beam is the Erlang virtual machine, like either Elixir or Erlang process. So you see this scalability here. So because the thread is really lightweight, so it's pretty common that you have like hundreds, thousands processes running on the same machine. I don't have a demo here myself now, but somebody gave a talk just on normal MacBook Pro, like 16 gig, they can spawn up like about 1 million or 2 million Erlang processes. And so that's pretty powerful. And each like a thread, when they starting, they only about like 6-7 kilobytes. So it's really, really small. And I remember one was using Ruby on Rails. One process is like a gig. So I can't even run on a micro instance on AWS. So and then this is just to me when I started using Elixir, when I look at all the processes, I was just crazy. And also because it's a functional programming for a programming language, Elixir or Erlang, and so there's immutable data structure is in place, and then also different threads, they don't share state, so they rely on messaging passing. So which means that so you can run as many like a process you want and do whatever the things that they won't interfere each other. They just so think about this. What do we normally do like with anything, any application, is that we take a data, come in, and we process some or do something about that data and return data out to somebody else, right? So that's pretty much just messaging passing. So that's exactly what Erlang does. And because each process, they only do one function and really like a lightweight, so once that function finished, so there's nothing within that function, because nothing is immutable, so like nothing in there need to be kind of kept, so they can be easily garbage collected afterwards. And so that's really efficient. And also, like the last bit I mentioned already about the communicate between different processes. And then so it doesn't matter when you write a program, you can just write the same way. You can run either on one machine or like 1,000 machines, because they're just same processes, and they're managed by the OTP platform. And fault tolerance. So this, I think this is a bit on the website as well. It's really true. I would kind of put a good few like applications into like a production, and there's always something will go wrong at a certain time you don't expect. And then so this, I mentioned a little bit about supervisor. Supervisor is just this OTP platform. So as it sounds, so it's a supervised processes. And what it does is, supervisor is like a OTP program. So it starts up, you start up your program, like if we go back here, so you start with link, just a TCP pool, and then you have a strategy. That's really important bit, the strategy part. So the supervisor has a few strategies, but to be honest, in other kind of like programming environment, they have different ones, but they're all kind of, they're not part of the programming language itself, or it's not part of the platform itself. There's a different software, different library. So this one is built in, and it also is like a battle tested. So Erlang been using them for like last 30 years. So this is supervisor strategies, one for one, which means if like this process somehow like crashed, and if you restart it. And one for all is like if one process crashed, if you restart everything, the whole application, all the processes. And the restful one is, so the supervisor built a supervision tree. So it's like a dependency, like a different, one application might have many dependencies. Actually that's another thing interesting in Elixir. All the dependencies, most of them are OTP applications, which means they'll have their own processes. The supervisor will manage them. And then so you have different dependencies. So you might have one application depends on multiple dependencies, and all those are like just their child processes. And all of them, they might have more processes afterwards. So one, like a restful one is if this process crashed, and then so all its like a child nodes, all those processes will get restarted. But itself will get restarted first, and all the child process will be restarted. But one for one earlier only restart itself. And the simple one for one, actually for the case is there's no child, like just one for one, only one process, they don't have a child process, so just really simple thing. So the supervisor, it is one of the most important bits of Erlang platform, the OTP platform, I say, because it's used both for Elixir and Erlang. And then Elixir itself is really extensible. And if you look at the source code itself, Elixir actually is written in itself. 89% of the code actually is in Elixir. So only 9.6% like is in Erlang. So they implement really basic things, and they use the macro system and to implement most of the stuff. And then so basically means you can create. I suppose macros and DSLs. I don't think I'm big kind of fan of writing a lot of them. But I think for language itself or maybe a framework, I think that's a good thing. But you just need to know how to write them. So tooling, that's one the best thing of Elixir, what it brings to the Erlang the Erlang platform. Like I said earlier, Erlang didn't have a really good story about the tooling stuff, and then so this when Elixir came out, so the first thing they built is called Mix. Mix is a build tool, and you can build different things or run different command line things. So you can see on this example here. So it just create a new Elixir application. It's really simple, called Mix New and app. If you create a set of like a really basic structure of an application and the configuration files, README files, even git ignore files, which are actually really handy. And then because they have a mix now, they can build different things, and then they bring this like a central like repository for all the kind of packages called Hex. So it's a hex.pm. So it's really similar to npm or like Ruby gems. You look at this though, they also support Erlang libraries as well. So Erlang have a package manager now, it's called Rebar Tree, and actually Mix is cooperated with that, and they work really well together. And then so actually Elixir itself actually bring this kind of like Erlang ecosystem and up to a different level, because before like Erlang people didn't really do it, but now actually people in Erlang world start creating libraries and putting on Hex as well. So Elixir itself actually embraced like the Erlang ecosystem as well. Interactive development, I suppose these days every programming language have like a repo. So IEX is just another one you created, but it has a lot of cool things about this. So IEX itself, not just a repo itself, actually itself is actually just an Elixir process, and in there you can do many different things. You can load the files in. And see if you look at the code here, it's all the H means help, so you print out the different like documentations. And then so the recompile here is actually you can, when you're in the shell, you actually can write your code in your editor, and you can load directly straight. You don't do execute shell to run a file or anything. You can just load, put a path in. If you load things in, and if you change something, you just run recompile. Even though Elixir is a dynamic language, why do you need to compile things? Because it actually compiled down to Erlang bytecode. So like many things that I did nowadays still need to be compiled to the Erlang bytecode to be run on the Erlang virtual machine. And then because I got Erlang compatible, that's a really good thing, because they're not just abandon the whole platform, and you can easily just import Erlang library and just use it. And with your Elixir code, there's no big problem. Only different the syntax, not syntax itself, it's just normally the modules in Elixir, they're capitalized, and then you can see there's Erlang libraries will come with a colon with a name, that's the module name of Erlang. So which means like it just, Elixir is still new kind of like a language, and then the ecosystem actually is growing really quickly. And but there's still some things just not there. But like you look at, but then because like Erlang been around for a long time, there's a lot of different libraries doing different things, and you can, if you can't find a library in Elixir, you can just use in the Erlang one, drop in, it should just work. And then just some other cool stuff of language itself, and then there's just a few examples here. So this, so the whole thing they try to do here is create a list of from 1 to 100,000, and then you map through them and then multiply every element by 3, and you filter them by the odd number, and at the end do a sum. And the first thing I want to talk about is eager loading and the lazy loading. So in Elixir they have like a module called enum, so which can loop through different kind of like collections and then do different like a normal functional programming stuff like map, filter, reduce. But they're eager, so every time, for example, if I create 1 to 100,000, there's a list of 100,000 elements, and then basically enum.map will map through everything and then pass the whole result to the next one. And then, so there's another thing, so then in Elixir there's a thing called a stream module. Stream is a lazy loading. So what this does is actually like it process one thing at a time and pass to the next one, pass the next one. It doesn't need to wait the whole thing to finish and to go through the next one. And but even really like 2 lines of code, I think that shows really kind of how cool Elixir is. First of all, is that's how you create a list. Just give a range, like 1 dot dot to whatever the number. And second thing, look at that 100,000. You know, that's like for developer productivity. Just you can write that way because you know that's 100,000. And instead of you write the big numbers, you don't know how many zeros you have, and you can write underscore in between here and then just like separate them out, but it's still an integer. And then second cool things about this is pipe. There are actually a few languages now all have a pipe operator, like F#, I think, and the Elixir was one of them. Like that was one of the first of them like created pipe operator. It's just really works similar to the kind of the pipe operator in shells like bash or like whatever. So what it does is like this is the things get piped through the next bit, and the result of the first bit will become the first argument of the next bit. So you can see this one. So this choose like is kind of this one using pipe, this one doesn't. So when you don't use the pipe, what you need to do so the last one enum.sum out at the end and in there into. So basically the most middle part is the most like the inside part is the first calculation. So you do a map first. So you look at this, just not as clear as this one. This one, so I have a list of 100,000 items passing to the next one. Also this AND thing, that's another cool syntactic sugar here. Is it means is like a function capture. So that means the first argument. So because when you do map reduce, you always use the first argument. So you do like a function x dot blah whatever. So this is kind of like and just means give me the first argument, give me the first like thing of this result here, and then do whatever it is. And then so but when you do pipe, you can see I have this list. I map through this, doing what like the first the element will multiply by 3 and do a filtering, and the next thing do a sum. Just really clear. But when you look at this one, I just like don't see it. I actually can read it. That's just some like a language feature itself. And so next thing is like as I'm a web developer, and so I'm always looking for a good web framework when I come to any language. And actually I dabbled like a Clojure back in the days. I really liked Clojure because I use Emacs myself. I always want to learn proper Lisp, and then did Clojure, really cool. But then Clojure never had this kind of like a good web framework gives you majority of the things. I did the Django with the Python web framework. I did the Ruby on Rails, the Ruby framework obviously, and they have different things. But Ruby on Rails, I didn't really like it because it gave you too much. And then at the end of the day, you didn't even know you were writing Ruby or you're writing Rails. And also a lot of things really like just really ambiguous. And the Django was a little bit better, but still they give a lot of things. But at the same time, to me, they're good in a way because when you want to start a web kind of project, you can get up and running literally like a few minutes. You have like somewhat like cross application there. You can test things out. But when I did Clojure, like even back in the days in Node, you have put in this framework, put this library. I think before you get started, you install 20 libraries first. And so Phoenix is like because the guy who created Elixir, he was like contributor to Rails. So he didn't create this web framework now. There's another guy called Chris McCord, and he's been working in the agency for many years. He created a lot of Ruby on Rails application, and then he was creating this chat app, messaging app. And then he just found, oh, Ruby on Rails is so bad at this because the process, like you only can have 10 processes a server. Every time you come a message is blocking. He tried to find a better way. He did a lot of hacking around different things. I think they used Sidekick or different queue systems, everything. So they did it, but still just really painful. So he saw Elixir, saw, oh, Elixir is brilliant. So he wanted to use Elixir for the things, but there was no web framework. So he created a web framework and using Elixir. And because Elixir is really extensible, so like he created a web framework, have some macros and some special kind of keywords. Well, keywords just based in the framework itself, but it's not Elixir keywords. And so you can use different things like controllers, get, put, all those kind of router and different things. So it worked out pretty well. And then Jose Valin joined the team afterwards, working with him and give me some pointers, and two of them actually leading this project. And they're just talking about a little bit kind of popularity here, because people think when they start using a new language, they will think, oh, is this language popular enough? Would they get enough support? Or would we get enough libraries or ecosystems around it? And actually both Phoenix Elixir on GitHub, they have more than 10,000 stars. So I suppose that's kind of compared to Django had 20,000 stars and Ruby on Rails had more 30,000 stars. But as compared to traditional framework, they only came out last year or so, and then a couple of years. So they got that many people showed interest. I think that's a good thing. So it's still growing. And also the companies who are using Elixir of Phoenix. So the big one, Pinterest has started using Elixir, but it just same as any new language itself, Node back in the days. A lot of people will start using them as a side project. They may be on different services. They might slowly convert it, and when they start seeing the benefits, and they will start massively changing their different stacks. And the Batch 365 actually is the first one actually write their whole stack from Java or something using Erlang and Elixir. I think mainly it's Elixir now, and they hired this agency called Erlang Solutions. They Erlang consultancies, and to help them to convert their technology to Elixir, because Batch 365 is about gambling stuff or betting stuff. So everything is super real time. So you have to be really high, really scalable, distributable, and also really responsive. So so this is again on Phoenix website, what they say is different. So it brings back the simplicity and joy in writing modern web applications by mixing tried and true technologies with a fresh breeze of functional ideas. What that means is, it's kind of marketing term, saying these things. But what it means, fundamentally, Phoenix is still another MVC web framework. You still have model view controller stuff, but at the same time, it has WebSocket support out of the box at first class, support from Phoenix team, and they have client-side libraries for web, Android, and iOS. And then because the nature of OTP or Elixir, the channel itself is to communicate with the WebSocket. The channel itself is just an OTP application. So if you write a chat, like a messaging app or an application, so every connection to your client is only really small, just Elixir process. Maybe only costs 7 kilobyte or 10 kilobyte. Compare you write in any other platform, gonna cost you a lot more. At the same time, if you want to scale it up, again, you can put another box on, and they just work out of the box, because between them they can even talk to each other if you have different services. And then, so how to deal with database, right? So Ruby on Rails have active record, Django have ORM, and most frameworks, web frameworks have ORM-ish things. Not saying the best thing, but to me, is as a web developer, it gives me a lot productivity. I don't have to write raw SQL unless I have to. And but I think everybody should know how to write good SQL queries. Just you can understand what the ORM do, what ORMs do. But some ORMs may be really slow on certain things. But then you can optimize that just writing raw SQL. So Ecto is a database layer which help Phoenix application, not actually in general, Elixir applications talk to the database. And then they use this repository pattern, so which means just basically you have a repository, you can actually connect to multiple databases, but at the same time the interface itself is quite like a standard, and which means actually if you don't want to use Ecto, it's fine, you can replace it with other things. And in fact, really interesting, if anybody interested, there's called Programming Phoenix programming book. And the first thing they did was they didn't use Ecto. They implemented their own how to deal with database stuff, and then later they replaced it with Ecto. Basically, just pretty much standard functional programming patterns. And the context is was only introduced recently from Phoenix 1.3. It's the most recent version of Phoenix, and it's about I don't know how many web developers here. People write web applications. Or just nobody, I feel. Yeah. Okay, so we also talk about this fat model slim controller. because people don't know actually where to put the kind of the functional code. Like either should it be in the model file, should it be in the controller file? But Phoenix introduced context is kind of layer in between. So where you put all the kind of like data manipulation or different things in there, and then the controller itself should just manage in the web interface. It's just you have a request come in, and in the controller you should do like just what you want to do in the controller, like give me the users, or give me these IDs, or give me this data. But the controller itself shouldn't do data processing. And then so a lot of people always saying like the data maybe should be in the model. But a lot of things like it's not really like model related stuff either, because model is really specific to itself. So you have like this data model maybe called user, and you have a few different like different attributes in there. But sometimes you might want to use a team, you might have a different model, but then you have to, in the user model, you have to talk to your team. So context itself is in between. For example, like for user kind of related stuff, you can create maybe one context, it's called accounts, and which dealing with different things related to users, and maybe like social logins or different things. Yeah, but it is like a really actually big change in a way, but at the same time it's not really, because basically just how things try to lead you to a better practice. They give you something you can use. Again, at the end of the day, everything Elixir, you don't have to follow what they give you. That's why I like the flexibility of Phoenix. You can just write pure Elixir you want, but at the same time, they try to guide you to a good direction, how to write good applications. Yeah, so okay, so that just, hopefully it's not, I feel it's a bit boring there, just Elixir and the Phoenix, and nothing about microservices. So now, so monolith or microservices. Again, there's pros and cons, and then to me, because I haven't used that much microservices, so I think I like monolith. Just kind of it's easier to manage, and a few team members work together. You all work on the same code base, right? So easier to talk things about, and then it's easier to manage only one Git repository, right? So there's not much like too many pull requests to look at. But then like also I feel pain because after like I put a lot of applications in production for the last few years, and then time by time I had to refactor stuff. And every time when I refactor the application, it's pain because everything connected to each other. I reach out, they should be just separate application. Why do they have to be in the same code base? So that's a debate. And probably is neither. There's a thing in Elixir called umbrella projects. Sounds just what it says here, like it's umbrella projects. You have multiple projects within umbrella. And before I talk about umbrella projects, this is just a graph I took from Martin Fowler's blog about when or why you should use microservices. And so you're talking about the productivity. So at first, like before your application get too complex, and then monolith is better because just like the reasons I talked about. And then later, but the more your application gets more complex, and then the developers' productivity gonna drop because the people need to understand a lot more stuff, and then maybe because the code are together, so people are lazy and they're gonna grab whatever around them, use it, so they don't really have a constraint there. So that happens. So the more complex, so probably you should think to switch to a microservice. But at the end of the day, though, I really like the last bit here. So if I remember, the skill of the team will outweigh any monolith or microservice choice. I really believe in that. I think people is the most important thing. Team is the most important thing. I feel like nowadays when I talk about design an application, write an application, a lot of things actually come to mind is how can the team work together? How can we distribute work between each other, but at the same time, nobody get too bored, work on the same thing, same time, people get to work a lot of things, but they have to focus as well. And I think a good team definitely will overcome any problems you have. So just a little bit side note there, by the way. And so umbrella project. So a lot of code. I didn't have time to find too many fancy pictures to put here to make it interesting. But yeah, so you create a project, put a little bit flag in there called umbrella. So you create a bunch of things. But look at this, it's called apps. It's a folder, nothing in it. And then so you go in there, go in that folder, and then you commit new project again. But this time you create in this, you don't put the umbrella in there. The supervisor, the dash sub is not really actually important. It is important in a way. It's like which means you tell Mix to create a project in a configuration. This is an OTP application. You need to be managed by supervisor. So in all of this, oh, this is a typo here. This now apps probably copy paste from that. That's actually created a lib folder. So that's where the code normally should be at. Like when you create the Elixir project, normally you have all these files. I have a lib folder, and everything in lib is your actual Elixir code. And then I created two projects. One is called API server. One is called data processing. And so you give me this kind of structure here. So you have apps, and you have API server, and two apps in this. Okay, so what does this do? Like, this is still kind of a monolith repository, well, monolith project, because they have this my project thing. But at the same time, in there you have two individual projects. They don't have to depend on each other. But at the same time, think about this, right? When you start you try to solve any problems, you are not 100% sure where is the boundary, where do you want to separate the concerns. You might design really well, but slowly, if you think too much ahead, you still at some point you feel like you made the wrong decision. So what Elixir try to push people to do is don't make decision too early, because okay, so one thing is when the two projects created in here, it's structure-wise exactly same as a standalone Elixir project. A little bit kind of configuration part you need to change, but in general the whole folder structures, everything is the same. And then so also in the umbrella project itself here, the config file, that actually is the whole umbrella project-wise. So it kind of can be used for both, like every apps you have in there. So at first, so it kind of decrease this overhead about, oh, you have to think this app needs this configuration, this app needs the other configuration. Both of them maybe even need the same app, but both of them need the configurations. Even though you don't need at first, you still need to write them. So this way is actually, they put those configurations for the whole umbrella project. You don't have to worry about them first. And then later, if you want to separate them out, you can just like put it, there's the same config files in each application as well. So this way to me is I don't have to rush to make my decision first. I can think about what I want to do with them first. And then like, okay, so maybe this might make sense, and create a few different apps and how it works. And then, so in there also, like especially microservices, you have to think what kind of interfaces you want to, different services talk to each other, TCP or HTTP, or even using queue system. But in this now, like you can do like, first of all, actually you can just call the module, just like they're in the same repository. But obviously because you're really conscious because of the different app, you still need to be consciously think, oh, you have to use this. So in the config file, you still need to put, in the individual config file here, you still need to put the other application as a dependency for this app, so you know you're using the other app. And then so, which means you have this kind of entry point for the other application. It's not just something grab to use, and then you have to you need to grab that in, and then to say, oh, I'm going to be using this, and then you can think the interface to talk to them. And then so, but first, actually, that's the thing. You can either use just normal way, calling a module, calling a function, do whatever it does, and also at the same time, you actually can use the OTP way, create a process and then talk to the other process, and which means afterwards you can easily split them up. And also same time, the benefits of this is you can take the second bit. First of all, is like when I design any applications, I talked to Richard earlier there about this, is like sometimes I might have a 3 or 4 repositories, they kind of relate to each other. And when I change one bit, I need to change other bit as well. So normally I need to send in 4 pull requests on 4 different repositories. And those 4, but then somebody had to review them, somebody had to like merge them. But when somebody put in one repository, they want to test the code, it won't work because the other repository had to be kind of work with them because they kind of depend on each other. So this way you have one this kind of mono repo, put them together, put them down, and then build the projects. Pull requests should be all up to date because it's based on the entire project. And then slowly when the projects, but the thing is, if you make a wrong decision tomorrow, it doesn't matter, it's the same thing. You create another app, or maybe you can merge these two together. You think, oh, those two actually should be in the same code base, and then you can merge them two together, and just change the interface there a little bit. That will do. And at some point, you might think this grow too big, take that out, put in a different repository, and then completely develop independently. And also, you could just even delete that thing. You say, oh, I have a Java service on this part doing this thing. I might just use that one. Yeah, so, but the problem with it is the deployment. I think microservices, obviously, you could use Kubernetes, but I never use Kubernetes, so I don't know how cool it is. I heard it's really cool. But in, Elixir itself has this package called distillery, which it does actually, you can just, so Erlang is really interesting. You can compile the entire Erlang application or Elixir application into a tarball. And that tarball itself is like a Golang. When you use Go, and you can compile everything in binary and just throw on a machine. And that tarball does exactly the same thing. So, but the thing you still need to compile. But if you have umbrella projects, it's kind of hard because you not have one project. How do you make sure what way do you want to run the one application as like a mono application? That's fine. That's easy. But you want to run them separately on different things, so you can use these two, and to create like this way. You can say release per app. So by release like two configurations and compile to two different tarballs, and you can deliver to different places. So there's another thing I didn't put in slides, I don't think. Yeah. So it's called e-delivery. So it's kind of Erlang delivery. So you can just put a little configuration file, and then automatically send your tarball once it's finished, and if you like send your tarball to your production system, and either you kind of are going to shut down like your current running Erlang process or like an Elixir process and replace it with a new one. And also e-delivery also does a little bit manage on how module reloading, which is a really cool feature of Erlang itself. Is actually you don't need to shut down your process, and that will automatically like you replace your code. So whatever the process is still using old code, once that's finished, they will use new code the next round. And then so e-delivery help you with that. So yeah, I don't know, like so at the end of the day, I think the Elixir approach is kind of like it's a better practice because you don't have to make too many decisions up front. You can start with a monolith, and then you can create umbrella projects, and then so within those you can create multiple apps, and then you can tweak them and you can make them work before and slowly, and then you can move them to microservices. Yeah, so the pipe operators obviously that's giveaway. Just want to show you how cool Elixir is, and yeah, so that's all. Thank you.